TIG welding in pipelines is a critical and highly specialized process used in industries where weld integrity, cleanliness, and precision are paramount. This includes sectors such as oil and gas, petrochemical, power generation, food processing, pharmaceuticals, and water treatment. TIG welding, or gas tungsten arc welding, plays a vital role in the fabrication and maintenance of pipeline systems that must operate under high pressure, in corrosive environments, or in systems where cleanliness is essential. Although not the fastest process compared to others like shielded metal arc welding or MIG welding, TIG offers unmatched control over weld quality, making it ideal for root pass welding and for high-specification joints. Pipeline welding is a demanding task due to several variables involved: diameter, wall thickness, material type, access limitations, and environmental conditions. TIG welding is especially favored for the root pass in pipelines because it provides precise control over penetration and produces a clean, slag-free weld. This initial weld is crucial because it forms the foundation of the joint. Any defects here can compromise the integrity of the entire pipeline. A high-quality root pass ensures proper fusion between the two pipe sections and sets the stage for any subsequent fill and cap passes, which may be done using TIG or other welding processes depending on project requirements. One of the primary challenges in TIG welding pipelines is the necessity for consistent and clean welds in varying positions. Since pipelines are round and often cannot be rotated during welding, especially in field applications, the welder must adapt to multiple positions such as flat, vertical, overhead, and horizontal within a single joint. These positional challenges require high levels of skill and experience. Welders must maintain consistent arc length, travel speed, and torch angle while maneuvering around the pipe. Gravity plays a role, especially in overhead and vertical up positions, requiring the welder to control the weld puddle carefully to avoid sagging or undercut. Purging is an essential aspect of TIG welding in pipelines, particularly when welding stainless steel or other corrosion-resistant alloys. Argon is typically used as a backing gas to fill the inside of the pipe and displace atmospheric gases like oxygen and nitrogen. This ensures that the root side of the weld remains clean and free of oxidation, which can severely degrade corrosion resistance. The purge process usually involves sealing both ends of the pipe section and using specialized dams, bladders, or paper systems to isolate the purge zone. Flow rate, gas purity, and purge time must be carefully managed. In high-specification environments like pharmaceutical or food-grade piping, weld discoloration, even if minor, can result in rejection of the weld. The pipe preparation process is another critical stage that affects TIG welding quality. Proper beveling, alignment, and